Welcome, everyone. You've probably heard about large language models, and some of them are used in ChatGPT. Many people see their future potential. However, it's crucial to understand how to apply this technology to your current applications or business. Today, we'll focus on one exciting potential usage: semantic or human language search. In this demonstration, we will show you how to empower an existing application with semantic search backed by OpenAI using just a few configuration lines, thanks to a library. For more details about the library, please refer to the description below. Let's get started. For this demonstration, let's assume you have a Spring Boot recruitment application, where you can navigate, edit, and display CVs of candidates. First, add the LLM integration artifact as a dependency and rebuild your application. Next, annotate your JPA entity class with provided by the artifact text to enable modification tracking. Correspondingly, annotate the TextGetter method to enable semantic search on the text content. Add a Spring configuration class to your main Spring class. Here, include your API key for OpenAI integration. That's it. With just a few lines of configuration, your search service is now available in your code. For demonstration purposes, let's add a mapping from entity ID to its UI presentation. Rebuild your application, and now you have a search form integrated. Let's test it out. The search results even find the entry with swdev, although it wasn't explicitly in the text, thanks to the context understanding of OpenAI. Now, let's create a new entry with CV copied from another entry and add Ooster as the location. The search yields the correct result, as Ooster is a town 20 kilometers away from Zurich, Switzerland. And, just for fun, the search even knows that Alice Barbie has white hair. Wonder why? Okay, how does it work? The provided sequence diagram showcases the sequence of interactions involved in achieving near real-time data enrichment within our application. Let's break down each step. The process begins with application initiating an update entry action. Upon receiving the request, application communicates with the JPA, Java Persistence API, to carry out the desired entry update. As soon as the update is made, the text update listener participant comes into play. It captures the updated entry's essential information, such as ID type and text, from the getter, annotated before. The text update listener then posts a message into message queue. The message serves as a notification to other components about the recent update. JPA commits the changes and returns control to the update initiator. The message processor reads the message from the queue and initiates further actions. Upon reading the message processor interacts with the vector DB to check whether update of embedding vector is needed. If necessary, the message processor communicates with an LLM, currently OpenAI, API. The interaction aims to initiate API request to acquire an embedding vector, a numerical representation of the text data. With the embedding vector in hand, the message processor stores it within the vector DB. Search process. The interaction begins with an user initiating a search request. This could be through a user interface or any other means of communication with the application. Upon receiving the search request, the service layer is activated to handle the request. The service layer interacts with the LLM, OpenAI, API to obtain an embedding vector for the search query. With the obtained embedding vector, the service layer searches the vector DB to find the nearest entry based on the vector's similarity. The vector DB returns the nearest entry, type/ID, to the service layer based on the similarity calculation. Once the nearest entry is determined, the service layer processes the response and redirects the request to the corresponding URL using a component referred to as UI mapping. Finally, the user receives a response from the application that corresponds to the search query. In conclusion, LLM and concrete OpenAI semantic search can be effortlessly integrated into your existing applications. With just a few lines of configuration, you can empower your business with intelligent and context-aware search capabilities. Of course, the enhancing your application can be more complicated. For example, you could have sensible data which you don't like to share with an external service provider. In this case, you can use some available open source LLM model on premise. The source code of the software is located on GitHub under MIT license and is open to contributions. In case if you need an assistance in integration, feel free to contact the author via links in video description.